Hey everyone, I hope you're doing well today. In this video, let's talk about graphing quadratic functions. While the three main forms of quadratic functions are intercept form, vertex form, and standard form, in this particular video we'll focus on quadratic functions being graphed when they're in standard form. Quadratic functions written in standard form will look like f of x is equal to some constant a times x squared plus some constant b times x plus some constant c. When graphing quadratic functions, you'll get this U-shaped curve that's called a parabola. Depending on the value of a, parabolas can be skinnier, wider, or flipped upside down. We'll get more into that in a little bit though. In understanding what makes parabolas look different from each other, let's explore the constants of a, b, and c a little bit more. Let's start with a. If the absolute value of a is between 0 and 1, or is a proper fraction, it's going to cause a vertical shrink, or the parabola gets wider. But if the absolute value of a is larger than 1, or is an improper fraction, then we're going to get a vertical stretch, or it's going to get a little skinnier. While I didn't write it here, if a is positive, the parabola is going to have a minimum, and if a is negative, then the parabola is going to have a maximum. As for c lets us know where the y-intercept of our parabola is. Hopefully this makes sense because the y-intercept always occurs when the value of x is equal to 0. If you plug in 0 into our quadratic function, everything cancels out except for the value of c. If you know the value of c, then you know the y-intercept of a quadratic function. If you use a and b together, you can find something called the A.O.S, or the axis of symmetry. If you take the opposite of b and divide that by 2 times the value of a, you're going to find the equation of a vertical line that divides a parabola perfectly in half. I'll show you a little bit more when we try some examples together. That brings us to the vertex. Once you find the A.O.S, or the axis of symmetry, the value of the negative b over 2a also ends up being the x-coordinate for the vertex, and if you plug that x value into the quadratic function, you'll get the corresponding y value for the vertex. Well, that's the general gist of it. I hope it's going to make more sense once we try a couple examples together. Here's how I've summarized how we're going to graph quadratic functions in this video. First, we'll start with identifying a, b, and c. Then, we're going to interpret what a, b, and c mean for us. After that, we'll use a and b to calculate the A.O.S, or axis of symmetry. And then we'll use our A.O.S, which is just an x value, to find the vertex of the parabola. And finally, we'll make a table of x and y coordinates and then graph our parabola. Now that we've gone over a bit of background, let's try a few examples together. If you'd like to give these a try on your own, pause the video now and go ahead and do so. If you'd like to do them with me, then just sit tight. Either way, I encourage you to grab some paper, something to write with, and let's do some math together. For example 1, we have f of x is equal to 3 times x squared minus 6 times x plus 4. And just in case you forgot, here are the 5 steps that we're going to follow together. And if you haven't memorized this information yet, here it is on the side to help us along this problem. For step 1, let's identify a, b, and c. This 3 here is going to be a, so I'm going to write a equals 3. After that, we have this b term of negative 6, so we're going to say b is equal to negative 6. And then finally, we have the c term of positive 4, so we're going to say c is equal to 4. Step 1 is now complete. Let's see what we know from looking at these constants. When a is equal to 3, that's a positive coefficient, so we know that the parabola is actually going to open upwards. What that means is it's going to have a minimum instead of a maximum. On top of that, because the absolute value of a is greater than 1, we know that there's going to be a vertical stretch here. This just means the parabola is going to be skinnier than normal. The other key takeaway you want to have is that when you know that c is equal to 4, that means we actually know the y-intercept for this parabola. The y-intercept here is going to be 0, 4. These are the main interpretations you want to take from knowing a, b, and c. Now it's time to find the axis of symmetry, or A.O.S for short. The equation for the A.O.S is x is equal to negative b over 2a. Don't forget at the end of the day that this is just going to give us the equation of an imaginary vertical line that cuts our parabola exactly in half. Let's go ahead and substitute some values in. So we have x equals the opposite of b, and b we know is going to be negative 6, we found that earlier, and that's going to be all over 2a. That's going to be 2 times the value of a, and we know a is equal to 3. In the denominator, 2 times 3 is equal to 6, so we can go ahead and write x is equal to the opposite of negative 6 over positive 6. And the negative 6 on top divided by the positive 6 on bottom is equal to negative 1, so we have the opposite of negative 1, and this just simplifies down to saying x is equal to positive 1. This right here is our axis of symmetry. We finished step 3 now. 1 is going to be the x value of the vertex, and to find out the y value of the vertex, or f of x, let's go ahead and substitute 1 into the function. We'll plug in 1 right here for x, then we'll plug it again 1 over here, and for a third time we'll plug it in right over here. Here's the original function, and to find out the y value, or f of x, we can say f of this positive 1 is equal to 3 times the 1 squared, we'll put that 1 right over here and go ahead and square it, minus 6 times the 1, we'll go ahead and substitute that in right here as well, and then add 4 on afterwards. Now just following the order of operations, this 1 squared is going to be 1, so we can write 3 times this 1 minus the 6 times 1 plus 4. Now, just doing the order operations a little bit more, we'll do both multiplications at the same time, so 3 times 1 is going to be 3, minus the 6 times 1, that's going to equal 6, and we have this plus 4 on at the end. After this, we're going to just go from left to right, following the order of operations. 3 minus 6 is going to equal negative 3, we have negative 3 plus 4, and we really only have one operation left, and negative 3 plus 4 is equal to positive 1. When x is equal to 1, we now know that y is also equal to 1. Combining this information together, we now know where our vertex is located. Our vertex is at 1, 1. That wraps up step 4, where we use the A.O.S to find the y value of the vertex. For step 5, let's clear some space and make a table and then a graph. When making a table, I suggest making it big enough so that you can fit 5 ordered pairs. It's important that we spend all that time finding our vertex so we can put the center of our table, which is going to be 1, 1. The reason why that's important is because remember that parabolas are symmetrical, so if we know where the middle is, if we know what the left side looks like, then we know what the right side looks like. At this point, we're just going to create some x values that are a little bit bigger than 1, like 2 and 3, and we're also going to choose some values that are the same distance away from 1 going in the negative direction, or 0 and negative 1. When x is 0 and x is 2, we're going to get the same y value, and when x is negative 1 and x is equal to positive 3, we're also going to get the same y value. Earlier, we knew that c was equal to 4, so that meant the y-intercept was equal to 4. So when x is equal to 0, that means y is equal to 4. Let's go ahead and write that in. And remember, that's going to be symmetrical, so when x is 2, y is also equal to 4. Now, for when x is equal to negative 1 and x is equal to 3, choose whichever one you prefer to use to find out the y value, or f of x, at that value. I prefer using positive values, so I'm going to use the positive 3. So I'm going to say f of positive 3 is going to be equal to 3 times this 3 squared, go ahead and write 3 to the second power, minus 6 times that 3, and we're going to add 4 at the very end. Following the order of operations, 3 squared is going to go first, and that's going to be 9, so we'll have 3 times 9 minus 6 times 3 plus 4. Doing both multiplications at the same time here, we're going to have 3 times 9, which is 27, minus 6 times 3, which is 18, plus 4. Continuing the order of operations and going from left to right, 27 minus 18 is going to equal 9, so we'll have 9 plus 4, and that's just going to be simply 13. When x was equal to 3, we now found that y was equal to 13. Let's go ahead and write that in our table. If we put it over here, we also know that when x is negative 1, y will also equal 13. Now that we've completed a table, let's make our graph. The least value for x is negative 1, and the greatest value is equal to positive 3, so let's go ahead and label those in. It looks like our y values range from 1 to 13, so let's see how we can fit those in as well. Skipping by 2's, it looks like we can fit in all our values here. To begin, our A.O.S, or axis of symmetry, was x equals positive 1, so let's go ahead and draw that in. This will help us see where the middle of the parabola is going to be. Our vertex, which is always located on the A.O.S, is going to be over here in quadrant 1, so I'll go ahead and plot that right down here. Then we can move forward with plotting some more points. 2, 4 is going to be to the right over here, and 3, 13 is going to be located up here. Symmetrical to the left side of the A.O.S, 0, 4 is going to be located to the left of the A.O.S. And for our fifth point, we have negative 1, 13, which is located all the way up here, but it's across from the other point, 3, 13. If we did everything correctly, we should be able to draw this U-shaped curve smoothly through all of these points. And finally, we now have a table and a graph for this quadratic function. For example 2, let's graph the quadratic function f of x is equal to negative 3/4 x squared minus 4x minus 1. Looking at this function, we can identify that the value of a is equal to negative 3/4, the value of b is equal to negative 4, and the value of c is equal to negative 1. Because the value of a is negative, we know this parabola is going to open down. If that's the case, then we're going to have a maximum instead of a minimum. Also, looking at the value of a, the absolute value of it is less than 1, so we know that we're going to have a vertical shrink. Basically, this parabola is going to be wider than normal. Knowing that c is equal to negative 1, we know the y-intercept. The y-intercept for this parabola is going to be 0, negative 1. That takes care of step 1 and step 2. For step 3, let's go ahead and find the A.O.S, or axis of symmetry. Remember, our formula is x is equal to negative b over 2a. Substituting in a and b, we have x is equal to the opposite of b on top, and that's going to be this negative 4. And on the bottom, we have 2 times the quantity of a, and a is equal to negative 3/4. Go ahead and write that right down here. 2 times negative 3/4 is equal to negative 3/2, so we can simplify this down and say we have negative 3/2 in the denominator, and we haven't touched that negative 4 on top, so let's leave it alone. Let's take this negative 4, which is negative 4 over 1, and divide that by the negative 3 over 2. And remember, when we divide, we're going to multiply by the reciprocal, so we'll take negative 4 over 1 times negative 2 over 3. You can go ahead and put the negative wherever you want, as long as it's on top or bottom, and that'll equal positive 8 over 3. Writing this in, we can say x is equal to the opposite of this 8 over 3 that we just found, or negative 8/3. This right here is our axis of symmetry. So we just finished step 3, which is finding the A.O.S, and we're now going to use that A.O.S to find the y value of the vertex. At this point, let's find f of this negative 8 over 3 to find out what the y value is for the vertex. Squaring this negative 8 over 3, we're going to get positive 64 over 9, so we can go ahead and write that. And now let's go ahead and multiply these at the same time. Rewriting this minus 1 so that we have common denominators, we can say we have negative 16 over 3 plus 32 over 3 minus 3 over 3. Now that we have common denominators all the way across, negative 16 plus 32 is going to equal positive 16, and positive 16 minus 3 is equal to 13. So we have 13 over 3. When the x value for this function is equal to negative 8/3, the y value is equal to 13/3. That's going to be the maximum value for this parabola. After all that work, we now know where the vertex is located. We know from the A.O.S that the x-coordinate is going to be at negative 8/3, and we know from what we just solved, we found out the y value, or y-coordinate, is going to be 13/3. Now that we found the vertex, let's go ahead and try step 5 and make a table and then a graph. So here's our table, and be sure to write the vertex in the center of it. Now let's go ahead and pick some x values that are above and below negative 8/3. So 0 is going to be 8/3 more than negative 8/3, and taking away 8/3 from negative 8/3, that's going to be negative 16/3. 0 and negative 16/3 are the same distance away from the vertex value. Picking another easy number, 1 above 0 is going to be 1, so if we go 1 below negative 16/3, that'll match. So in terms of thirds, that's going to be taking away 3/3, which is the same thing as 1, and that'll say negative 19/3. Whatever the y value for 1 is going to match the y value for negative 19/3. We knew from the c value that the y-intercept was 0, negative 1, so we can go ahead and write that right over here, and that's going to be the same for the negative 16/3. Now let's go ahead and plug in either negative 19/3 or 1 into our function to see what the y value is at those locations. I don't know about you, but I'm going to find f of 1. At this point, let's go ahead and rewrite these using common denominators. After all that work, we should be able to find out that when x is equal to 1, y is going to equal negative 23 over 4. That's going to be our y value when x is equal to 1. Let's go ahead and write that in our table. Now that we have 5 ordered pairs we can use, let's go ahead and make our graph. First we'll draw the A.O.S, which is just a vertical line. And there it is, x is equal to negative 8 over 3. Now let's go ahead and plot our vertex, and the y value is going to be at 13/3 or 4 1/3. And of course it's located on the vertex, and we're going to go ahead and plot that right about up here. Here's where 0, negative 1 is going to be. And for negative 16/3, negative 1, that's going to be at negative 5 1/3, negative 1, and that's located right about here. While I don't have enough space to plot the negative 19/3, negative 23 over 4, we can plot its counterpart on the other side, which is 1, negative 23 over 4. That's going to be 1, negative 5 3/4. So we can write 1, negative 5 3/4 right about here. While I have 4 out of the 5 points, that's enough to draw our parabola. And this is what the parabola would look like for example 2. For this third and final example, I'm not going to talk through the problem. If you'd like to try this problem on your own, feel free to pause the video right now and go ahead and do so. While I'm not going to talk through all the steps for this example, I will still show all of them on the screen. Here's A, B, and C. Knowing that A is equal to 1/2, here's what we know about this parabola. There's step 1 and 2, and now for the A.O.S. The vertical line, x equals negative 1, is our axis of symmetry. Now let's go ahead and use that to find out the vertex. Substituting negative 1 in for x, we can find that f of negative 1 is equal to when x is equal to negative 1, y is equal to negative 3 1/2. At this point, we now know where our vertex is located. Its x-coordinate is at negative 1, and its y-coordinate is at negative 3 1/2. Now that we found our A.O.S and our vertex, let's finally make a table, then make a graph. Here's an example of a table that will be helpful to make a graph. When x is equal to 1, y is equal to negative 1 1/2. Now that we have a table with 5 ordered pairs, let's make our graph. And there you have it, this would be the parabola for the quadratic function in this example. I really hope that this video helped you understand how to graph quadratic equations a little bit better when they're in standard form. And if it did, please consider giving the video a thumbs up and leaving a nice comment in the comment section down below. As always, keep up the great work, and I'll see you in the next one.